What's going on, everybody? This is Mr. Diamond, and this is going to be the video where I'm going to go over a bunch of name to structure examples. We're going to do a bunch of name to structure examples. I had 3 of them that I showed or 4 of them I showed at the very end of one of the videos, and I'm going to actually add a 5th one. We're going to call this 5th one, we'll do, how about... Let me make sure I don't have one like that. Okay, I do. So we're going to do 4 methyl, and then we're going to do cyclo non-an 1 all. So I'm going to also do a 5th one, a bonus one on here. So I've got 3-ethyl 4-hexanol, heptanal, 5-ethyl 2,3-dimethyl octane, butane 2-one, 4-methyl cyclo non-an 1 all. So adding in another more difficult one and one that has cyclo in it that we didn't do. So we're going to start with the first one. So we've got 3-ethyl 4-hexanol. And I'm going to actually switch to a pencil just because when you're doing some of these structures, the way the words go and the order they're in may require you to actually change around how you have things numbered and where your positions are. So highly recommend you do this in pencil. Even cocky Mr. Diamond will do these in pencil because he knows that just the nature of these problems lend themselves to being a little bit screwed up. I just have to track down a pencil. Okay, we got our pencil. Hopefully it's going to be dark enough for you guys to see. I'm going to add a couple more pieces of pencil lead to it. You would think I would have prepared for this, but as you've realized, I am the most professional of all of the teachers you probably will ever have in your entire life. All right. So what we want to do, and the way I like to think about these, is I like to make sure I know what every piece is going to mean. So for example, I've got a hexan right here, a hexan. Actually, I will use a little bit of colors just for this, the breaking down what each of the pieces means parts. So I've got a 4-hexan. Hex means 6. No, that pin's not working, so we're going to get a different color. So hex means 6, and then an means all single bonds. Okay, so that's the first piece of information that we've got. Let me zoom in so we can see a little bit better. So hex an is 6 all single bonded carbons. So I'm going to go ahead and I will actually sketch over here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I always like to double check and count whenever I do it. So there's my 6 all single bonded carbons. We've got an OL that is an alcohol. Now, there's 2 ways that this could have been written. This also could have been written as hexan 4 all. This number 4 out front isn't attached to the hex. It wouldn't make sense for it to be, oh, there's a parent chain of 6 on the 4th carbon. So this 4 is actually going to the alcohol. You can do this whichever way makes the most sense to you. You can put the 4 out front of this because this piece tells you the number of the parent chain, and this tells you any major substituent. Or you can do hexan 4 all. Either one of those is fine. Let me tweak my focus a little bit. My focusing stuff on these cameras has been a huge pain in the booty. So let's go ahead and get this fixed over here. There we go. Much better. Okay. So that means there is going to be an alcohol on position 4. So we're going to start numbering 1, 2, 3, 4, 5, 6. So on position 4, I'm going to have an alcohol. I'm going to add my OH. And then finally, we've only got one other really group to deal with. We've got a 3-ethyl. So I'm going to go to position 1, 2, and 3, and an ethyl that is a 2-carbon chain. No, just completely blocking your view. So ethyl means there's a 2-carbon chain because methyl, ethyl, and that's attached to position number 3. So on position number 3, I'm going to do 1, and you can go whatever direction you want. I'm going to choose to go this way. And we'll clean it up a little bit, get rid of my little guide numbers. You don't need to put those. In fact, if I was doing this not for a video, I probably wouldn't have put them at all. But if that doesn't make you feel happy, you could also go over it in pen when you're done, or you could redraw it. I'm going to go over it in pen to make it a little more visible for you guys. But this structure right here, that bad boy right there, is 3-ethyl 4-hexanol. Okay, so hopefully that makes sense. We're going to go ahead and jump down to the next one. The next one is heptanal. I'm going to try not to bump into the camera too much. So we've got heptanal. All right, we've got a heptan piece. It's our parent chain piece right there. Hept means 7 carbons. And means all single bonds. So we know our parent chain is going to be 7 carbons with all single bonds. So I'm going to go ahead and draw that. Got 1, 2, 3, 4, 5, 6, 7. And then we've got an Al ending attached to it. We've got this Al right here. Al stands for aldehyde. And because it's an aldehyde, and because there's no number implies that it's on the very first carbon. So if this was my very first carbon, that means this is where the aldehyde is positioned. And I mentioned it a little bit in class. Because aldehydes, if you remember, an aldehyde is a double bonded oxygen. There's a carbon on one side and there's a hydrogen on the other. They have to be on the edges. You can't, because there needs to be a hydrogen over here. You can't have an aldehyde in the middle. If an aldehyde is in the middle, it's no longer an aldehyde. It becomes a ketone. So we're without a number here. That implies that it's in the first position. So the first position could be right here. 1, 2, 3, 4, 5, 6, 7 carbon chains with an aldehyde as the first position. This would be heptanal. And remember, we could have put it on the other side because these things are 3D. We could flip them around. We could rotate them in space, and they would be taking up the same locations, or being put in similar locations just from a different angle. So there we go. There is my heptanal. Okay, I'm gonna try to move this arm without causing too much chaos in the world. So we're gonna slide it down here so we can do our last example on this page before I have to flip it. This one's going to get a little more complicated, just a little bit. We've got 5-ethyl, as I annoyingly scratched the camera, 2,3-dimethyl octane. All right, let's break down our pieces just like we've done before. So octan, or octane, in this case, it doesn't have an ending. It's just ane. So this means that there are 8 carbons, all single bonded. So we're good to go ahead and 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. You'll notice I always double count just in case I don't want to accidentally have it screwed up. Okay, and then we've got our 2 other pieces. We've got a 2,3-dimethyl. So dimethyl means there are 2 methyls on position 2 and on 3. So methyl is just 1 carbon. There's a 1 carbon chain, and it's going to be on position 2. So I'll just put one right here. And on position 3. So I'll put one right there. And then our last piece is a 5-ethyl. It's a 2-carbon chain on carbon number 5. So we're going to count to carbon number 5. 1, 2, 3, 4, 5. We've got a methyl, and then a second one will make it an ethyl group that's attached to it. There's no other functional groups on here, which makes sense because we didn't modify our octane. It just stayed as octane, which is implying that it's just single bonded carbons throughout, no special functional groups. So there is our 5-ethyl 2,3-dimethyl octane. Okay, I actually think I can fit the last one on here. So this last one, or at least I can fit one more. Well, we'll have two more. The first of which being butane 2-one, or this could be called 2-butanone. Let's get our pieces broken down. So butane, methyl, ethyl, propyl, butyl. So that's 4 carbons with all single bonds. And then 2-one means on carbon number 2, there is a ketone. So butane is 1, 2, 3, 4. And then on carbon 1, 2, we have a ketone, which is just a double bond to an oxygen. And that is it. Butane 2-one or 2-butanone. Either one of those is okay. All right, instead of getting a new piece of paper, I'm going to go ahead and do this on the same piece of paper. I'm just going to rotate it to some blank space that I got right here. So our last example is definitely the most complicated. We've got 4-methyl, 1-cyclo non-an. Well, I put the 1 at the beginning on accident. I actually just misread it because I was trying to read it sideways. But we'll go ahead and just do it this way. 4-methyl, 1-cyclo-nonanol. Or the other way it would be 4-methyl cyclononan-1-ol. Technically, you don't even actually need the 1. So you actually could also write this as 4-methyl cyclononanol, which is just even weirder. But all three of these would mean the same thing. So let's analyze our root pieces. Let's look at our words that we've got. So we've got nonan on all of these. Although I apparently misspelled the bottom one. Non-an-all. So nonan, 9 carbons, all single bonded. But this time we do also have the addition of cyclo. So it is also in a circle or a ring. The all must have this 1 going with it, or it's got it right here, or because it doesn't have a number associated on carbon number 1, there is an alcohol. And then this first piece is all the same. On carbon number 4, there is a methyl. Try not to knock my mic off the table. So we're going to go ahead and combine all of these things together. This is one where pencil is definitely a good idea. So we're going to go 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, 10. It's not a perfect circle, but I started making it as though it was 8. I forgot it was actually 9. 1, 2, 3, 4. This is where I started, right there. So 1, 2, 3, 4, 5, 6, 7, 8, 9 total carbons. And then remember, because this is a ring, even though I've made it not a nice, neat, pretty ring because I'm just bad and I don't want to have to keep rewriting it, we can start numbering any carbons in any location. So on carbon number 1, which could be literally anywhere, I'm going to choose right here. I've got an alcohol. And then 1, 2, 3 away, either direction. It doesn't matter which direction. 3 away. So I'm going to do to the left. 1, 2. So this is carbon 1, 2, 3. Carbon number 4, there's a methyl. There's a methane or a methyl group just hanging off the side. So this right here would be our 4-methyl 1-cyclononenal. Don't worry if your rings don't work out super well, especially if it's an odd number of sides. It's really hard to get them to work out nicely, so just don't freak out about them too much. Okay, those are all the examples I got going from name to structure. I hope that makes sense. If you have any questions, please send me an email about it. We'll be working them out in class all week as well, so this is just an extra video you can go back to and look at. This is Mr. Diamond signing off. Hope you have a great rest of your day.